Okay, this video is to help you get started, okay, on the substitution lesson, okay, solving systems of equations with substitution. Okay, you guys have solved systems of equations, but you've done them with graphing. Okay, you graphed both lines and you saw where the two lines intersected. Okay, there's many different ways to solve a system of equations, but we're going to look at a couple more this week. Okay, and the first one that we're going to look at is called substitution. Okay, so let's say you have two equations that are in the system, but they're not even necessarily in slope-intercept form. So they're not, simple, easy to graph anyway. Okay, we're going to use what's called substitution. Okay, the big idea, if two things are equal, we can substitute one for the other. Okay, so if I have 2y minus x equals 8, 3x plus y equals negative 3. Well, my goal is to first get something equal to y or something equal to x. So I want to have x equals blah, 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 or y equals blah, blah, blah. Okay, from either one of my equations, I want that to happen. Now, what I would do, I would look for an equation that has a coefficient of positive 1, just because that's so much easier to solve for a variable. Okay, so that first equation, the top equation, the y has a coefficient of 2, the x has a coefficient of negative 1. Okay, the x coordinate on the bottom equation has a coefficient of 3. Okay, but the y on the bottom equation has a coefficient of 1, which means that is simple, easy to solve for. Okay, so to solve this for y, to have y equals, I can just subtract 3x from both sides. I'm just going to subtract 3x from both sides. And when I subtract 3x on the right, I'm not going to have like terms. Okay, I cannot combine them. I'm just going to have y equals negative 3, it's already there on the right, take away 3x. So negative 3 minus 3x. So I solved the bottom equation for y. Okay, the second step is to plug that in, to substitute that in to the other equation. Okay, my other equation is 2 times y minus x equals 8. Well, if y is equal to negative 3 minus 3x, I can substitute y with negative 3 minus 3x. You're thinking, why would I do that? The reason I'm going to do that is now I can solve this equation because look real carefully here. I have only x's. I have all variables that are the same. So now if I have an equation where all the variables are all the same letter, all the same variable, I can solve it. So that means I can solve this equation and find out what x is. So I just need to solve this multi-step equation that I get after I substitute and figure out what x is. So I'm first going to use the distributive property. See, 2 times negative 3 is negative 6. 2 times negative 3x is negative, I was looking at that wrong. Okay, negative 6x. I still have the minus x. I still have the equals, and I still have the 8. Okay, so I have negative 6 minus 6x minus x equals 8. Okay, keep solving. Get your like terms together. The negative 6x and the negative 1x is negative 7x. So combine those together. So I get negative 6x, negative 7x minus 6 equals 8. Okay, I'm going to go ahead and I'm not going to show every step, but I'm just going to know that I'm adding 6 to both sides. I'm going to add 6 to both sides. When I do that, I'm going to have negative 7x with nothing else on the left because my 6 went away. 8 plus 6 is 14 on the right. So I have negative 7 times x equals 14. Okay, now I'm going to divide each side by negative 7. I get x equals negative 2. Okay, so that's half of my answer. Half of my answer. X is equal to negative 2. My x coordinate is negative 2. Okay, I just need to now find my y coordinate. Okay, to find my y coordinate, I can substitute this x value. I could actually go into either of the original equations if I wanted to. Okay, it'd be fine. But boy, it'd be a lot easier if I went into the transformed equation when I solve for y. It's just easier to go back to that one than it is to the other two originals. Okay, but you can do what you want. See, if I have y equals negative 3 minus 3x, and I now know what x is, it's going to be a lot easier to go back into this. So I'm going to go back into y equals negative 3 minus 3x. I'm going to put negative 3 minus 3. I'm going to put negative 2 in for x. So I get y equals negative 3 minus 3 times negative 2. Okay, I need to multiply the negative 3 and the negative 2 together first. Okay, that's positive 6. So I end up with y equals negative 3 and then positive 6, negative 3 plus 6. So then y equals positive 3 because negative 3 plus 6 is positive 3. Okay, now I have the answer. My x-coordinate was negative 2. My y-coordinate is 3. So my solution is negative 2, put the x-coordinate first, negative 2 comma 3. Okay, if I wanted to check my answer, I could now take that x-coordinate and y-coordinate, put it back into both equations, and make sure we get true statements. Okay, so usually I would just say do this in your head, but if x is negative 2 and y is 3, okay, for that top equation, I got to put y in after the 2. I'm going to type in x after the minus sign. Then I'm going to have equals 8. So I could check that real quick. 2 times 3. 2 times 3 is 6. 6 minus negative 2, okay, which is the same as plus positive 2, gives me 8. Okay, so that equation checked out. Okay, plug in these numbers into the second equation. Okay, 3 times x plus y equals negative 3. So 3 times my x, which was negative 2, plus my y value of 3 must equal negative 3. If we did this right, this is going to pan out too. Okay, let's see. 3 times negative 2 is negative 6. Add 3 to that, and yes, we do get negative 3. Okay, guys, this takes practice. And I'm going to have the solutions available for you guys at home to check your answer. But please let me know if you run into any trouble. It's tricky at first, okay? But just do the best. Do the best you can.